All right, so let's take a little break from probability and go to Pascal's triangle. So this will actually tie into probability, but for now, we're just going to stick straight to what is Pascal's triangle and how can we use it to distribute. So this dude back in the 13th century found this pattern of numbers. You start with a 1, you end with a 1, and the next number is the sum of the numbers before it. So right here, 1 plus 2 gives us this 3, 2 plus 1 gives us that 3. 1 plus 3 gives us this 4, that gives us a 6, 4. And then we do that again. Start with a 1, 5, 10, 10, 5, and end with 1. So by themselves, these numbers don't seem too interesting, but they actually represent some very, very useful things. If we look at, let's say, 3C2, that's a 3, okay? If we do 3C0, it's a 1. 3C1, that's 3, so 1, 3, 3, because, 2 is a 3, see that? And then we do 3 here, that's a 1, 1, 3, 3, 1. So row 3 is all the combinations for a population of 3. So 0, 1, 2, 3. Interestingly enough, let's see what happens if we expand this binomial right here. We're going to use the distributive property. Yeah, it's going to take a minute. I would not suggest copying this down if you're doing notes. I would suggest waiting until the end and then seeing what happens, because this part right here is not that useful, but you need to see it to see why we're doing this. So it's the third power. So I'm going to do it 3 times. A times, so I'm just going to do these 2 first, because I can't multiply these 3 things at once. I'm going to multiply 2, and then I'm going to multiply that answer by the next one. So that's going to be a squared, AB, EA, which is the same as AB, B squared. Multiply that by A plus B. Combine my like terms first to make my life a little easier. That's 2 ABs. All right, so now I'm going to distribute A to everybody, then I'm going to distribute B to everybody, and then I'm going to combine my like terms. So that's A cubed to A squared B plus AB squared. I like writing in an alphabetical order, personally. B times A squared B to AB squared B cubed. Combine my like terms. Again, I'm going to put descending order starting with A's. So A cubed. I got 2 A squareds and another A squared right here. It's A squared B, so that's 3 of those things. Let's see, now I'm going to go with A to the first and A to the first. Got 1 and 2 makes 3 AB squareds. And I got B cubed. Now I'm going to stick a 1 here and a 1 here. And don't those numbers look a little familiar to you? That's row 3. So for expanding a binomial, raising a binomial to any power, we can skip all the work if we know Pascal's triangle. We know the coefficients that they will have at the end. All we have to do is figure out what goes in the middle. So here's the whole formula thing, blah, blah, blah. What's going on here? So we have our coefficients from Pascal's triangle. We start with the first term. I'll call it A since it is A. And we raise it to the third power. Well, every time I go down the line in Pascal's triangle, I'm going to reduce the first term's power by 1. 3, 2, 1, none. And I'm going to increase the second term's power, b, by 1. 0, 1, 2, 3. That's it. Literally, that's how you raise a binomial to any power. Now, if we have something other than 1, I'd highly advise using parentheses and using a calculator. We'll get there. So that's the formula. Again, if you don't have Pascal's triangle handy, you don't want to make it, you could actually just say, what's my first, first is always V1. What's my second one if it's a row 3, it's n is 3, so 3, see, my second number would be 1. Oh, my third number is going to be 2. Okay, so it's 3, 3, 3, 3. Or you can choose Pascal's triangle, your choice. Or you can do all the work by hand. Entirely up to you, really. This time we got 5, though. So if I go look at Pascal's triangle, 1, 5, 10, 10, 5, 1. I would highly advise writing down the coefficients before you do anything else. 1, 5, 5. Don't think that's right. I forgot, so I'm just going to use my calculator. We're on row 5. My first number is a 1. My second number is a 5. I think my third number is not 5. I really did forget. It should be a 10. Okay. 5, 1, I think. 1, 2, 3, 4, 5. No, double the 10. My next number, if you forget, you can use your calculator. 10. And then it's going to repeat itself. It's going to go back down. 1. All right, so that's my coefficients I'm going to use. I have the 5th power starting with a, so that's 1 times a to the 5th plus 5 times, reduce the power of a, increase the power of b. Every sum of your exponents should be n. So n is 5, that's 4 plus 1 is 5. Every time. Reduce a by 1, increase b by 1. Same thing. Same thing. And finally, I've got 1b to the 5th. And that's it. And if it's, x plus y, or even x plus 2 is something easy, like, or x plus 1, you could real quick and easy do this. If you have other numbers other than 1, it does, you have to do a little bit of arithmetic there. And we're going to do that in a minute. 7. So these two are pretty much the same thing. I'm going to do one. I'm going to do number 2. They're the same. You just go with Pascal's triangle. This would just take way too long. That's just annoying. Pascal's triangle, 7. So we could, use Pascal's triangle and write it all out. So I don't want, okay. I want row 7, I think. There we go. 0, 1. So it starts with row 0, by the way. Starts with row 0. 1, 2, 3, 4, 5, 6, 7. And you can see it's 2, 3, 4, 5, 6, 7. That's the row you're on, right there. So here's 7. You could use that. 1, 7, 21, 35, 35, 21, 7, 1. 7, 21, 35, 35, 21, 7, 1. I should have 8 terms. I should always have one more term than n. Let me count. 1, 2, 3, 4, 5, 6, 7, 8. Good. I actually remembered them. Cool. Surprising. And of course, you could just use your calculator. If I want the 1, 2, 3, fourth term, if I want the fourth term, I do 7 stacked to 0, so I'm going to do 7C3. That will give me my fourth term, 35. However you get them, get them. Write them down. Now we're going to use them. 1x to the 7th plus 7, reduce x by 1, increase y by 1, plus 21, reduce x by 1, increase y by 1, 6 plus 1 is 7, 5 plus 2 is 7, so far so good. I'm going to definitely have to use 2 lines here. Just keep going. Reduce x by 1, increase y by 1. Always add up to 7. Just go down here. And there we go. So you just literally write it out. If you have coefficients of 1 here, it makes, like, it's just easy. It's done. Easy peasy. So we just literally get Pascal's triangle. Look at row 10. Those are my coefficients. It's CD, so that's going to be 1 C to the 10th, 10 C to the 9th, C to the 1st, and just keep going. I don't see a point in doing that. So going on to number 4, where it gets more interesting. Now we've got a number that is not 1. Use parentheses. Use your calculator. Write it out. So row 6. 1, 6. I know those two for sure. 15, 20, 15. 15, 20, 15. And once it starts going back down, I know it's got to mirror itself. Evens have a single number in the middle. Odds repeat. So like here you see it's got 35, 35. That's what happens when it's odd. There's my coefficients. Let's just do the thing. So if you're on your paper at home, you might want to turn it sideways or just make sure you have space. Don't start at the bottom of the page, start at the top. 1 times x to the 6th. So far, so good. Plus 6 times x to the 5th. What is my b this time? -3 times -3 to the 1st plus 15 times x to the 4th, and that's going to be -3 squared plus, and then that's 20 x to the 3rd, -3 to the 3rd, plus 15 x squared, -3 to the 4th, plus 6x, -3 to the 5th, almost fit it, plus 1 times -3 to the 6th. Okay, so that's x to the 6th, easy enough. 6 times -3 to the 1st power, well, that's -8. I can do that one. I can do that one. Then it gets 15 times -3 squared. That's going to be 9. Just use a calculator. You're going to need it. Don't try to do it in your head. Just don't. 15 times -3 second. 135. X to the 4th. Move that over there. Let's see, that's going to be a 3 here. That's going to be a 20 there. -540. x to the third. That's going to be a 4. That's going to be a 15. Positive 1215 squared. Getting some big numbers. It's okay. It's okay. Got to calculate for a reason. Negative 1458. Sure, why not? Calculate. Give me the math. Just trust it. And then 7.9. It's 9 to the third power. Anyway, so that would be the answer. Done. That's it. Next problem. Yeah, let's find an interesting one. And I'm not going to give any powers higher than 5 because it's just going to take forever. So let's look at this one. This one's interesting. This is going to be the most difficult I'm going to give you. How will you use this? Well, you'll probably use it to square binomials. Like you have 2x plus 3 squared. You can use Pascal's triangle instead of multiplying it all out. Or you just multiply it all out, your choice. But let's go with this one. And we'll call it A. So this time, A is 3p, B is negative 2q. So this is A. And this whole dang thing right here is B. Don't forget the negative. And it's 5. Let's go. So row 5, 1, 5, 10, 10, 5, 1. 10, 10, 5, 1. 1 times 3p to the 5th. Plus 5 times 3p to the 4th. Negative 2q. I would go p's and q's together. The first. Plus 10 3p cubed. Negative 2q squared. Plus 10 3p squared. Negative 2q to the third. Plus 5 times 3p times negative 2q plus 1 times negative 2q. So let's put this in the calculator now. So this is 1 times 3 to the 5th. That was easy, 243 p to the 5th. So this exponent's going to go on there. That's nothing tricky. Let's look at the next. We've got 5 here. We've got 3 to the 4th. And then we have negative 2 to the first. Negative 810. P goes down by 1. Q goes up by 1. Okay. Now we got a 10 there. That's going to be a 3. And that's a 2. And 80, positive. 10 again. 3. 2. And we get negative 720. 5. That's going to be 1. And that's going to be 4. 40. And finally, that's going to be a 1. That's going to be a 0. That's going to be a 5. Yes, you could just type in -2 to fit. That'll work too. You get -32. Oops, I put plus. Plus -32. And that's it. That's as complicated as I'm going to give you. There's nothing else to it, ladies and gents. Let's see what the next thing is. Well, that's just a summary. Total number of terms is always n. The exponent is, first term is n. So this one's going to have it start with n. This is going to start with 0. The exponent in a decreases. The exponent in b increases. Sum is always going to be n. Coefficients are, I have no idea what they want here. It's from Pascal's triangle. There's n plus 1 of them. I honestly have no idea what they want to put here, but they follow the nth row of Pascal's triangle. And we can go look and see what they're trying to find there. Maybe binomial? Let's see, do I need to delete this? No, okay. Now you get a preview of what we're doing. Let's see what they're trying to put here. Okay, look, all your answers to your homework. So they wrote it all out. That's just way too much work, if you ask me. Symmetrical. Symmetrical, really? Really? Okay, whatever. And that's it, done. See you later, deuces.